Good morning, everybody. Thanks for coming to the Data Colada seminar series. I'm Leif Nelson, and today I want to welcome our speaker, Quentin André, as well as our panelists, Ellen Peters, Craig McKenzie, Stein van Osler, Nick Reinholtz, and Jennifer Trueblood. In addition, we're joined here with Joe Simmons and Yuri Simonson, who will be part of our panel today. For all of you, we encourage you to listen and engage. The best way to do that is by submitting questions or comments through the Q&A function at the bottom of your screen. Those questions and comments will be seen by all of the panelists, and it'll give us an opportunity to respond. I discourage you from using the chat function, which also sends messages somewhere, but it turns out is considerably harder for us to understand and regulate. So you use the Q&A. We won't get to every single question you submit, but we will get to some, and all of them will get to Quentin at the end of the talk. So don't worry, even if we don't address it, he will still be able to see it. Okay, that's the basic stuff. So Quentin, the floor is yours.
Thank you very much, Leif. And I'm very, very happy to be here today and to thank you for giving me the opportunity to present this project, Learning Price Dispersion, with my great co-authors, Nick Reinholtz and Bart De Lange. So what I'm going to start with is a small, a small anecdote. So as some of you might know, I recently moved away from the Netherlands to Colorado, to the mountains. And so it means a lot of changes, of course. I lived in Europe my entire life, so the US is an entirely different continent to explore. But one of the bigger changes for me was that after a lifetime of relying on public transportation, I finally had to do something I swore I would never do, which is buy a car. Or actually not buy a car, buy a Subaru. Because when you move to Colorado, you have to buy a Subaru. That's the only option available to you. And so my wife and I started browsing. We saw a model, a make that we like, the option that we like. And so we start looking online for prices. And the first price that we see is this one, 18K. And so if you're like me and you never shopped for a car in your life, this price is entirely meaningless. You don't know if that's a good price, if that's a bad price. At the bare minimum, what you would need to have is some information about the average price that you could get from a car. From that average price, what you can tell already was that this is cheaper than average. So you could think this is a good price. I might go for that. But when you're buying something as expensive as a car, what you would need actually is more information than this. You not only need information about the average price, but you would need some sense of the overall variability of prices. For a simple reason is that it can tell you, one, if you could get a cheaper price than the one you're currently looking at, and second, how hard or easy it would be to find a cheaper price. And so those beliefs about the overall dispersion, about the overall distribution of prices beyond the central tendency is something that we call dispersion knowledge. So this dispersion knowledge encompasses all the beliefs and judgments that people have about the variability of an outcome. And so, of course, it can apply to variability of prices in a category, but it can also apply to other things, such as how regularly can you expect your bus to arrive in the morning, or your month-to-month variations in your income and expenses, or your second-to-second variations in your GameStop portfolio. So this is the sort of things that we'll be talking about today. Those beliefs that people have about how variable a numerical quantity is. And in particular, what we're going to focus on today is variability of prices. Now, why does it matter? Because these dispersion beliefs, those dispersion knowledge is a normative and descriptive input in many decisions. Why do I mean by normative? Is that according to the models of human behavior, people are supposed to incorporate it. And descriptive, meaning there's a lot of evidence that people, in fact, do use cues about dispersions to make decisions. Which decisions? Well, again, across many domains, those findings have been documented. People use price dispersion to evaluate prices. That's the car example I mentioned. They use it to decide how long to search for a better price, something that we call search depth or search length. It's a fundamental result of the search literature that the amount of search should depend on the variability of prices. The more variable they are, the more you should search, because the more favorable result you could ultimately get. Choosing which insurance to buy, depending on how large of your medical expenses you're expecting to pay, or how expensive you expect your car repair to be, you're going to choose different insurance policies. It will influence, of course, the saving strategy. How much should you set aside on a blocked account? Well, it depends how much you're earning each month and how much you're spending each month. And it can even influence things such as political support. There's evidence, for instance, that people's beliefs about the dispersion of income in a society influence their support for redistribution. So really, it is a fundamental part of judgments and decisions across many contexts. Now, the interesting thing about it is that there is another normative assumption, is that people can form those dispersion beliefs from experience, meaning by repeatedly making decisions, repeatedly sampling from a category, they will accumulate information about the dispersions of those outcomes and being able to accurately remember them and use them in judgment. And so, again, this assumption has been present in model of choices under ambiguity, in decisions to buy durables, in search models, in stockpiling decisions. But in practice, when we started looking at empirical investigation, so what do I mean by empirical investigation? I mean studies that have looked at specifically people's ability to form accurate beliefs about the numerical distribution that was presented to them. So people are shown a number of prices, a number of values, and so they are asked to report their beliefs about the variability, how accurate people are. And so what was interesting to us is that the literature is largely pessimistic. One, there's few investigations that have looked at disability that people might or might not have. And second, the conclusions are largely pessimistic, suggesting that people are not very good, in fact, at learning dispersion. And so for us, that was kind of a puzzle, because if it's really that important, if it's really that much of an input in many decisions, why don't we know more about it? And so I cannot read the minds of previous researchers or say exactly why a topic has been looked at extensively or not, but we have one intuition, is that it's kind of hard to measure dispersion knowledge. If I ask you, hey, what's the average price of a Subaru? People can put a number on that. They can give you a dollar amount. If I ask you, what's your average medical expenses? You can also give a dollar amount. But what about dispersion knowledge? What if I ask you, how variable or predictable were your expenses last month? It's not something that people can easily put a number on. And so why is that a problem? It means that past research had to offer other solutions to look at dispersion knowledge. And some of the solutions that they've offered is either verbal ratings, so questions like, are prices likely to vary significantly across stores? One problem of that is, one, they are not measurement invariant. It's all context dependent. What does it mean for something to vary significantly, right? And so we cannot compare it to a normative standard. We can say if people are accurate or not when they give us these judgments. Another approach that the papers have taken is to give people a definition. So, okay, the standard deviation is the average square deviation for the mean, or the variance is the average square deviation for the mean. You're going to compute it and tell us what it is. Well, not surprisingly, if you ask people to do that and they don't do it well, you cannot say if it means that they've not been able to process dispersion, or if it means that this is nonsense to them, that really they don't understand what you're talking about. So that's again a challenge. And the other approach that they've taken is they give people two distribution and they tell them, hey, okay, which of the two had more variance? Or give us the ratio of the variance of one distribution to another. But again, that's a challenge. One, because if people don't understand what variance is, they are going to give you nonsensical answers. And second, they're psychological perception of dispersion might not necessarily map onto the concept of variance. And so when you're going to test whether they're accurate or not, you will not be able to obtain interesting answers. There's another problem with asking people to compare to distribution. I'll come back to it in a second. And so the project that I'm going to present today, we decided to have a deeper look at people's ability to learn dispersion and to learn price dispersion in particular. And so what we're going to do, in contrast to previous research, one, we're going to rely on intuitive measures of dispersion knowledge. One, we're going to rely on people's perception of the minimum or maximum price that they encountered. So again, this is something that people can put a dollar amount on. So no problem with understanding here. And we're going to rely on graphical methods. I'll come back to this in a second. The other thing that we're going to do is we're going to test dispersion learning, not just of a single category, but people's ability to learn dispersion in a multi-category environment. So they're presented, when people are presented with prices from different categories, can they learn independently the price dispersion of those different categories? Why is that interesting? Well, first, this is how people learn. If you look at a typical learning environment, if you look at a supermarket, at online shopping, on Zalando or Amazon, or even car rentals, every time people are rarely browsing one category at a time. They see prices from different categories, sometimes sequentially, sometimes intermixed. And so to make good decisions, they must not be able to only to learn price dispersion, but to learn it in the category specific way, to form independent representation of dispersion for those categories. So that's the first thing. That's the substantial interest that we have in this question. The second thing is, if you remember what I said 3 minutes ago, hopefully, I said that past investigation have tested people's ability to learn dispersion by asking them to compare the amount of dispersion that was present in two categories. But if people cannot answer this question, it might mean two things. It might mean one, that they cannot learn dispersion, period, or it can mean that they have a hard time forming category-specific impressions of dispersion. And so there's also an interest from a scientific perspective here, from a theoretical perspective, to separate those two constructs and to being able to identify why in previous investigation, people were not so good at learning dispersion. Any questions so far?
Quentin, I'll just maybe make a couple of comments, ask questions. So you're probably familiar with Peterson and Beach's 1967 review paper, because I think they concluded at that time that people were pretty good at assessing variance, as I recall. Sometimes they'd give too much weight to outliers, or differential weight to outliers and so on. So that's one thing. So, but if you're familiar with that research, then it doesn't really matter. The other thing is, variance, you put up that definition of variance, but, using squared deviations, but that's just sort of for mathematical convenience. You could just use average deviation. It doesn't have to be squared. And the squared deviations give a lot of weight to outliers, for example. So there are some disadvantages to using that, maybe as a psychological model. And the other thing that just crossed my mind is, although you're going to talk about high and low, is you could ask people for confidence intervals, right? So 50, and there's a large literature on people's confidence intervals, and maybe ask people about a 50%, a 90%, an interval such that they're 90% confident that that the values lie within that interval and so on. So just some comments about perhaps different ways of thinking about it.
No, this is great feedback. I will be talking about the graphical methods that we're using in a second that actually relates very closely to this notion of confidence interval, while actually giving people a finer ability to express their beliefs about price dispersion and the shape of the distribution in general. And as for your comment on whether people's psychological definition of dispersion might map onto variance or just average deviation, this is not something that we'll talk about today, but as I will mention at the end of the talk, it's definitely one of the things that we want to explore in the future. What is basically the best mathematical approximation of what's going on in people's mind when they're learning price dispersion?
So, Quentin, I don't know the literature very well, and I don't know what you're gonna tell us in terms of graphical methods, but it seems to me that even things that we think are simplified might be really difficult for people. I think that maybe things that people might be able to do is, if you've been searching for Subarus, that you might be able to basically take 100 imaginary Subarus and put them in price bins, which would give you something that might look like a bell curve.
And that's exactly what we're going to do.
Okay. So another thing, sorry.
No problem.
Sorry for being so naive. Another thing that I was wondering is, why is it important for me to learn dispersion if in a lot of contexts now I can just order, for example, rental car prices by price from low to high? Why do I need to learn the dispersion?
Yeah, so that's a great point. It's true that now with website and search aggregators and all that, there's a lot of decision aids essentially that are lessening the need for this dispersion knowledge. But still, I believe that there are many contexts in which, like the car example that I mentioned, when you're approaching a purchase, when someone offers you a price at the dealership, you cannot easily pull out the prices of all the other dealerships in the neighborhood.
You're right. Yes, and it's true that if I walk into a store, I still need to know whether a price that I'm seeing there is a good price or a bad price. Right?
Yeah, but it's true that, and it's in fact been an interesting development in marketing. A lot of websites have been developing indicators to how consumers navigate this dispersion knowledge. Now, I will be presenting studies on people buying flight tickets, for instance. Now, a lot of search aggregators are giving a recommendation, like you should buy now, you should buy later, like this is a very low price, this is a very high price. And so they're helping consumers navigate this complexity. But it's still not everywhere. And so I believe that it's still important for people to have this knowledge. Okay. So a few words about the experiments and the data. All the materials, data, and code is posted on the OSF. Some studies are pre-registered, others are not. This is a project that started a long time ago, so some studies are not. But for the studies that are not pre-registered, I can tell you that sample size was determined in advance, all deviation conditions are reported, and all exclusions, if any, are reported. And as much as possible, we also report robustness checks for the non-pre-registered studies. And so today I'm going to present a trilogy of study. In the first part, I'm going to provide evidence for something that we call dispersion spillover. I will show you that it has consequences across a wide range of consumer relevant decisions. And I'm going to talk about what this bias reveals about the cognitive underpinning of dispersion learning. And so if anyone has a great singing voice, now's the moment. No? Okay, let's go. So study one, testing dispersion learning. So this is when you need to pay attention, because this paradigm that I'm going to describe here is a paradigm on which we're going to rely throughout the studies. So basically what we did, we recruited participants, generally online on MTOR, but we have a few online studies as well. And we asked them to learn prices that are described as prices of items from two different categories. So in that study, we showed them 26 prices that we describe as prices of red wine, and 26 prices that we describe as prices of white wines. And the prices are shown to participants every 1.2 seconds in a sequential randomized order. So this is what it looks like in this study. Okay, so they learned all the prices in this way. Now, the trick is those labels, red wines, white wines, they only matter for the participant. They don't matter to us. What is important, what you need to know, is that one of those categories was assigned a price distribution that was always common, always identical across conditions. That's what you see on the screen in orange. The prices range from 17 to 34. Right? And so this distribution was common across all three conditions. What we manipulate is the price dispersion that is assigned to the other item. And we manipulate it at either a low level, top panel, medium level, middle panel, or higher level. And so what this design allows us to do is, one, we can test people's ability to accurately report the amount of dispersion that they learn. And second, we can check if their perception of dispersion in the common category can be independent of the amount of dispersion that they encountered in the manipulated category. And of course, we counterbalance whether the red wines that are manipulated or the common category. But we never found any effect of this counterbalancing factor, so I don't elaborate on it in the results. Everything is clear? Okay, so that's really the basic part.
Hold on. So I'm sorry if I'm misunderstanding. So the non-target one is not manipulated. That always has the same range?
Yes, correct. So let's say white wines have, sorry?
How do you know if kind of the bleed over from that non-focused category comes from what you showed them versus from what they know about that other category from the real world?
Because we counterbalance the labels. We counterbalance whether the white wines are the common category or the red wines are the common category.
Got it.
And we never found any effect in any of our studies. So I'm not going to elaborate on this one, but it's an important factor that we needed to control for.
I have another question, Quentin, if I could.
Yes.
So if I understood your design, if I understood your methodology, people are not controlling the search themselves. You're presenting everybody gets the exact same information presentation.
Exact, except that the order of studies is randomized. So
yeah.
The order of prices is randomized, sorry.
At some point, will you look at allowing people to do their own search? Because you may expect differences if you allow that.
That's study 2. And
great.
Yes.
Yep.
Thank you. Okay, and so for this study, we use very simple DV. We asked them for each of the 2 categories that they learned, so red wines and white wines, to report the maximum price that they remember seeing, the minimum price that they remember seeing. And we also tried a verbal measure to ask them to report how unpredictable and inconsistent the prices were. But as you might expect, we never got any interpretable results using those questions, because this is not something that people can make sense of in absolute terms. So I'm going to focus on the first 2 DVs here. So what we find first, so those are the results for the manipulated category. On the top panel, you see the minimum price that people report. On the bottom panel, you see the maximum price that people report. So the first thing to get from this is that people are sensitive to the amount of dispersion that was presented. They accurately report a higher minimum price and a lower maximum price when the manipulated distribution had low variance, in between when they have middle variance, and a lower minimum price and a higher maximum price, that is a larger distribution, when this distribution indeed had a higher amount of price dispersion. So that's not too surprising. It confirms that people can indeed attend to the amount of dispersion that's presented and report on it. What is more interesting is this result. When we look at the common distribution, we should expect, in the absence of any cross-category influence, that people report the same minimum and maximum price across all 3 conditions. We don't find that. We systematically find that people report a larger distribution for the common category when the manipulated category also had a large amount of price dispersion. So this asymmetric assimilation effect, that is a higher dispersion in an unrelated category, inflates people's perception of dispersion in a focal category, is something that we call the dispersion spillover. So that's our key result. And what I'm going to describe in the next study is that, one, this result is stable across many contexts, and it has important consequences. So another way of looking at this is the cumulative distribution of responses. When, for the common category, when the manipulated category has low or medium price dispersion, we find a good discontinuity at the true minimum price at 17. See that a lot of people nail that. They get that right. On the other hand, when the manipulated category had a higher amount of price dispersion, we see that very often people exceed this minimum price. They report a minimum price that's lower than this. and we see the same pattern for the maximum price. So really, people seem to have relatively precise insights about the bounds of the distribution that they learn, unless another unrelated distribution had a larger amount of price dispersion, in which case it's extending the distribution beyond its true bound. So that's the two takeaways that I want you to get from this study, that people learn dispersion. There's clear differences in the perception of the manipulated category. There's good accuracy when the two distributions have an homogeneous amount of dispersion, but that people struggle to learn the category-specific amount of dispersion, such that a higher amount of dispersion in another category inflates their perception of dispersion.
So Quentin, I have a quick question here.
Yes.
So how much does this depend on the categories being semantically related? So you have white wine and red wine. If you had white wine and books or garden tools, something completely unrelated, do you think you would see the same result?
We have a study on which that I will not describe today, on which we get tentative evidence that this is moderated by category similarity, but still present when the two categories are completely different. We use wines and smartphone cases, for instance.
Okay.
Quentin, another thing is they're not just sort of semantically related, they're very perceptually related as well. So, and then also the distributions overlap. So do you get this if the distributions don't overlap?
Yes, so we get it with different presentation formats when the distributions do not overlap and with semantically different categories. That's part of the results I will present, but the effect seems pretty robust in any sequential presentation format when people go through prices one at a time. So in study 2, we did a different learning phase. People could learn the prices at their own pace, so they were clicking on those cards to reveal them one at a time. They took longer, and the categories were also different. In that study, we used pillows and blankets. You can preview it. I have a preview link in there. If you're curious later, you can go through the study and see for yourself what it looks like. And also materials, data, and codes are posted. In that study, what we changed is we changed the elicitation technique that we use to measure people's perception of dispersion. Now, if you've been following the Data Colada seminar series, you've seen this before. This is called a distribution builder, and it essentially allows people to represent the subjective perception of a distribution by allowing balls representing outcomes to buckets representing range of prices. And so what we ask people here is simply describe, using this tool, all the prices that you remember seeing in each of the two categories. So for the pillows and for the blankets. And again, we had manipulated the prices of the pillows and the blanket as previously. And so how do we analyze this data? Well, we can take the true distribution that people learn, right? That would be it in one condition. This is a distribution that one participant would construct. We look across all the distribution that participant constructed, and we can check if the dispersion of the distribution that participant constructed match the true amount of dispersion that was presented. And so the nice thing with this distribution builder is that previously we were constrained to look at just the minimum, the maximum, and the range. Now we can look at dispersion in any given way. We can look at standard deviation, we can look at variance, we can look at interquartile range, and we obtain consistent results across all those measures. And so again, what we find is that when we ask people about the manipulated category, they report a wider amount of dispersion when the dispersion of that category was low versus moderate versus high. And when we look at the common category, we again see that when the manipulated category had a higher amount of price dispersion, people report larger distribution. And so this is looking, for instance, at one outcome, the standard deviation. This is for the manipulated category. And again, for the common category, this dispersion spillover. So again, people are really good. That's something that I want to emphasize, because as JDM researchers, we love to point out what people do wrong, but I think it's actually impressive how accurate people were when the two distributions had the same amount of price dispersion. So this is the true distribution that people learn.
Could I ask a quick question? Could I ask a quick question, Quentin?
Yes,
so you showed the average learning, that the average learning is pretty high, but I assume you have variance there. What do any individual differences map onto that? I would expect, for example, based on some past research by Nate Diekman and some others, that people who hire in numeracy, for example, for a variety of different information processing reasons, would search for longer and would end up spending more time on the numbers and would ultimately end up having more accurate distributions.
Absolutely. So we do not look at all at individual differences in this project, but indeed, based on past research, we would expect that people higher in numeracy, higher need for cognition would perform better at this task, and presumably the magnitude of the dispersion spillover would be attenuated among those people.
And one other, thank you. One other quick question: are you always using a normal distribution, like in terms of the data you present to them?
Not always.
Okay.
Not always, and we also find consistent results when we don't. Okay, so this is the true distribution that people learn. This is the median distribution that people report. There were only 11% off target. And so that's what 11% off target is like. So they really had this amazing ability to reproduce the range and the dispersion of the distribution that they learned. Unless, again, the other distribution had a larger amount of price dispersion, in which case their perception of dispersion became contaminated by this information. So again, we replicate this with other prices distribution, when distribution have different means, when manipulating variance, keeping the range constant, with other learning phases, and with other product categories. Now, the second part of the trilogy, as I told you, is to look at the consequences of this dispersion spillover. Because one possible concern when you document a new bias like this one is that this is somehow an artifact of your particular study, of the way you ask the question, right? And that would not necessarily show up in the important decisions that people make based on dispersion information. And so in study 3, we are going to see the influence of this dispersion spillover in the context of judging the attractiveness of prices. So in that study, people see 52 flight prices described as flight to Florida and flight to Colorado. To facilitate learning, we color-coded the prices and we used a small pictogram for each type of price. And we have a slightly different design this time, where we have one common category again, one manipulated category, but the manipulated category is only manipulated at 2 levels, either to have equal price dispersion or higher price dispersion. And so this is what the stimuli look like. Now, after people learn the 52 prices as before, we ask them to focus on the flights to the common category. So if Florida was the common category, we ask them focus on the flights to Florida, such that they are going to answer questions about a distribution that had a category, that had the same amount of price dispersion regardless of the experimental condition. And so we ask them, as before, what is the lowest price that you remember seeing? And again, we observe the same pattern. People are really good at reporting what the true minimum price was, unless the other category had a larger amount of price dispersion. And then we see people a sequence of 5 prices, and we ask them, for each of those 5 prices, how likely would you be to accept it versus search longer for a better price? And so the 5 prices that we show them are 280, 260, 240, 220, and 200. Now, the interesting result is that 240 is the true minimum price that they saw. And so if you look at people's responses in the equal dispersion condition, you see that the likelihood to accept the price increases linearly up to the true minimum price. And then there is this discontinuity where any increase beyond this true minimum price has a minimal impact, right? This is normative. They already reached the ceiling of what the best price is. And so any price decrease beyond that should have a minimal impact. If we look at the results in the higher dispersion category, we see two things. One, the average stated likelihood to accept the price is lower. They believe that lower prices are available, and so it lowers overall the attractiveness of all the prices that we show them. The other thing is that this discontinuity as 240 is no longer here. We see a pretty linear slope all across the range. Again, 240 is no longer a special price for those people because they believe that lower prices are available, and so they react differently to further price decreases. In study 4, we extend this result and look at an actual, yeah, Jennifer?
I have a couple of questions for you. So how do these effects depend on the number of samples that people see? So in most of your studies, you have about 26 per category. If you vary that, how does that influence both their estimation of the min and the max, but also then what they prefer to choose, like in your flight task?
It's a great question, and I don't have an answer to that. What I would expect is that there would be some trade-offs, I'm guessing, because more prices give more information, but also people, particularly in online experiments or any experiment really, have limited attention. And so there might be diminishing sensitivity, but the truth is we need to test that. We need to look at this empirically and whether this changes as a function of the number of values that people have sampled.
Yeah, so one of the things that I'm wondering is when people are trying to determine which price they'll accept in your flight task, I guess there's two things I'm sort of thinking. Like, first, do they have a really good sense of what the stable environment is for the standard you saw? Like, was 26 enough? So if you showed them more, would they be more likely to be, or would they be less likely to be influenced by the other category? And also, two, do they believe this environment is non-stationary? I mean, do they believe that it's possible that things could change? So, you know, one category was had a higher dispersion than the other. So perhaps there is a belief that in the future, you know, the category that they're making a decision about could actually change. And so therefore it makes sense to potentially search more.
So for the second comment, we address that. We tell them explicitly the prices should be similar to the one you saw. So we don't know if they trust us, but at least we tell them you have no reason to expect that they will change. Regardless, the first comment about whether people incorporate information from the other category because they believe that they have limited information, I'll talk to this if I have time at the end. We believe that that might be one of the reasons why people are using dispersion information from the other category. In a nutshell, dispersion statistics are biased in small sample. And so it would make sense for people to pool dispersion across category in the same way that when we do a t-test, we pool dispersion information across conditions to obtain a better estimate. And so it might be the same thing that's happening psychologically. I'm getting ahead of the talk a bit, but since you asked the question.
Yeah, thank you.
No problem. So in study 4, we extend this paradigm to a search task in a more realistic paradigm and also a more involving paradigm because it studies incentive compatible and per-registered. So what we do in this task is we tell people you're a businessman, you're often traveling to 2 destinations, to Colorado and to Florida. And so since you're often traveling to those destinations, you subscribe to price alerts that your travel agent is sending you. And so you're going to review the past 26 notifications that you received. And on each notification, we display side by side the best price available to Colorado and the best price available for flight to Florida. This is self-paced, so people could go through the prices at their own rhythm. And it's otherwise identical to the previous study in terms of the design. Now for the DV, we tell them, now you have a business trip coming up. In 7 days, you have to fly to the common category. So again, they all answer questions about a category that had the same amount of price dispersion. And we tell them, you're going to see the daily prices currently offered on each of those 6 days leading to your flight. And you can choose on each day to buy or to wait for a new offer on the next day. So this is a search task without recall in search lingo. And to make this incentive compatible, we tell them you have an allowance to buy the tickets, and any money that you save from this allowance, you will be able to use it on foods and drinks at your destination. And to convert that to a real incentive, they would receive a bonus depending on how much money they save on the flight ticket. And so this is what it looked like. We tell them 5 days before departure, this is the price available. What do you want to do? You want to buy, in which case it ends, or you want to ignore this offer and see what price will be offered tomorrow. And again, we clarified that this was a stationary environment. So there's no reason to expect that the prices presented in the next 7 days would differ from the one that they learned before. And so when we look at search depth, we see that, so the sequence of prices offered was identical for all participants. This is to make it easier on us for the analysis. And so given the sequence of prices, the third offer, a price of $2.60, is clearly the best offer. It's the utility maximizing offer. This is the offer that people should pick. And so what we see is that in the equal dispersion condition, people got this right. When they see this offer, which is very close to the minimum price that they learn, they choose it and the study ends. In the higher dispersion condition, we see that people become more likely to pass on this utility maximizing offer. They search for too long. And so they miss on the best option and they end up paying more in the end and receiving a smaller bonus. And at the end of the study, we asked for their memory for the cheapest flight to see again if this is what's driving the effect. And yes, again, we see that people have a distorted memory for the true minimum price that they could find. So I'm going to skip some material here, but just to give you a bird's eye view of other results, we did the same thing in the context not of price search, but rather of accepting or rejecting offers. So we told people there's 2 types of bonuses that we pay for 2 different types of study, red studies and blue studies. And we revealed to people that, hey, you're now in a blue study. Do you want to accept this bonus? Again, a sequence of boxes that they can open representing the bonus. If they discard it, they cannot go back. And so we again find that people earn a lower bonus when they were in the higher dispersion condition. Again, this was incentive compatible and pre-registered. So to us, that was really an interesting study because people on MTurk are motivated to earn money. And so this is the most ecologically valid paradigm. They are really incentivized to make the best decisions here. This is their goal. Again, that was driven by their memory for the maximum bonus, this time being distorted. And finally, the last context that we look at is bidding. Because when you're bidding on an item, the optimal strategy in an open bid context is to bid a higher price than the second highest bid, but not too high of a price, to keep as much value for yourself. And so again, we show them previous bids for 2 different types of items, for an Amazon gift card and for a Whole Foods gift card. And then we give them the opportunity to bet on an Amazon gift card, which had a common amount of price dispersion across condition. And we find again that they bid too much when they saw bids for another item that were more dispersed, that were higher. So that's the conclusion. I hope I convinced you that it's not just a cute artifact of the way we ask the question, but it actually has meaningful consequences for people's ability to make good decisions in a multi-category environment. Now, the last 12 minutes, I want to devote them to something that we're really excited about. We think that this bias reveals interesting things about the cognitive underpinning of dispersion knowledge, of how people represent dispersion in their mind. For people who are not familiar with this literature, there's roughly 2 models that are describing how people make sense of categories. There's the exemplar view and the prototype view. So to use an often used example, let's say you're trying to determine if a particular animal is a bird. According to the exemplar view, what you would do is you would pull out from memory a sample of animals that you previously identified as birds, and you would compare the target animal to each of them to see if they're similar to the other things that you've classified already as birds. The prototype view takes a slightly different perspective. It says that people abstract features. They describe categories as a set of features, not necessarily as a set of examples, but as common characteristics that are tying the different exemplars together. So going back to birds, people might have learned that birds have feathers, and that birds tend to fly, and that birds tend to lay eggs. And so to determine if your animal is a bird, rather than comparing it individually to the different birds that you have in memory, you would look, does it have feathers? Is it flying? Does it lay eggs? Now, how do this apply to distributional knowledge, right? To the price knowledge that you have about a category. Well, according to the exemplar model, let's say you're trying to determine if $28 is an acceptable price for a smartphone case. Not the smartphone case. According to the exemplar model, what you would do is you would pull out smartphone case prices from memory, and you would compare this focal price to the different price that you encountered. According to the prototype model, what people might do also is they might not only have these prices in mind, they might have abstracted intuitive statistics to represent the set of prices that they previously encountered. For instance, they might have a very good sense of what the average price was. There's in fact a lot of literature showing that it is the case, and that people intuitively, almost automatically extract the average, the central tendency of a category. So one way through which they could judge this price is it far or away from what I think is the average price in the category? But that's not the end of it. What might also happen is that people do not only form an intuitive average of the category, but also form an intuitive sigma, an intuitive statistic of dispersion that tells them how dispersed, or on the contrary, how tight the prices in the category were. Now, those two models, they make similar predictions in general, and the general consensus is that knowledge, category knowledge, is a mix of exemplar judgments and prototype judgment. And so there's been a lot of debates about whether they can be distinguished or not, whether they might actually be the same thing. But we think that in the context of dispersion spillover, they make slightly different predictions. Because what would dispersion spillover look like from an exemplar perspective? You're trying to judge if 26 is an acceptable price for white wine. If you only compare them to the price of white wine, you would conclude no, too high. But if people accidentally confuse some prices of red wines for prices of white wines, they might determine that this is an okay price. So this is exemplar confusion. That's one tentative explanation for the dispersion spillover. According to the prototype view, what might happen is that rather than forming the prototype of how dispersed the prices are, only considering the white wines, they might do it, going back to Jennifer's comment, across all the prices that they encountered, pulling them together. And so in that case, they might decide that it is, in fact, an acceptable price. Now, how can we set them apart? First, exemplar confusion makes an interesting prediction when two distributions have different means versus the same means. What are those predictions? Well, if you look on the screen, and I show two distributions. In one condition, they have the same mean. In another condition, they have different means. If people have a tendency to confuse exemplars, to remember them as belonging to the wrong category, what should happen? First, we should observe a mean spillover. That is, people will report an average for each of the two categories that's pulled apart, right? The average of the blue distribution would be somewhere here, and the average of the orange distribution would be somewhere here. That's the first result. The second thing is we should find greater dispersion when the two categories have different means versus identical means. Again, they would wrongly remember prices that's outside of the range, and so they would make them wider. And so to test that, in study 7, we manipulate, rather than manipulating the dispersion of the distribution as in previous studies, we manipulate the average price. And we see if we observe this predicted pattern of results. The answer is no. When we look at the mean of the reported prices, we see that the means of the common distribution are mostly unchanged. And so I know that non-significant doesn't mean no effect. If you're curious, there's in the paper a bunch of comparisons that we make to reasonable H1 alternative hypothesis, and this pattern of results seems more consistent with the null than with those other alternatives. And if we look at the range again, we don't see the patterns of result that we would predict, where if this was driven by exemplar confusion. Now, this rules out the boring, uninteresting explanation of dispersion spillover in our view, which is that people just confuse values from one distribution to the other. Now, how could we rule in that people form intuitive statistics of dispersion? How could we find them, identify them, provide evidence that they're present or absent? What we did in the last study is that we presented distributions that do not overlap. So here the design is slightly different. We have two categories and we orthogonally manipulate whether they have high or low dispersion, okay? And so why is this design interesting is that let's say we observe the same pattern as before. We replicate the dispersion spillover. That is, when the distribution with the high mean has high rather than low dispersion, we should observe that the distribution in black becomes wider. Now, where it gets interesting is that for this distribution to become wider, it would mean that people would have to report prices that were never presented, that never appeared in either of the two distributions. So this price of 20, for instance. Now, this price of 20, you can still describe it using a more sophisticated exemplar model. How would this price of 20 emerge? It would come from people remembering a price of 16, people confusing a price of 28, and the people interpolating between the two. They think I saw 16, I saw 28, so maybe there was a price at 20 in between. This is still something that can be accommodated by exemplar model of judgments.
I have a quick question here about some of the assumptions. So you're assuming that the numbers are being encoded exactly correctly. So if I see a 16, then I would, in my exemplar model, I would have a 16 in my head. But what if there was some noise in that? And there's reason to believe that would be the case. We know that there's the approximate number system, for example. So I see a 16 and I encode that incorrectly. So I still have an exemplar model, but now there's just noise in terms of each one of these items. So if that's the, I mean, can you rule out that possibility?
So if there were just people being fuzzy, having a fuzzy memory for numbers, we should not observe a higher number of those phantom prices, that's how we call them in the paper, when the other distribution has wide versus tight price dispersion, right? We should observe that this is just random error, and there's as many of those 20 when the distribution with the high mean is tight versus large, right? There's no reason to expect that there would be systematic differences between conditions if it's just people encoding an approximate value. And so that's one way we...
Unless your encoding is context dependent, right? I mean, I don't know. Like, it's not clear to me that this would automatically rule out.
No, that would rule out the most rigid...
more complex versions of an exemplar model about the encoding of information, the encoding of exemplars, particularly numbers. So I think the way that we might encode numbers might be a bit different than, let's say, pictures of birds and other animals. So I don't know, it's just something to think about. I don't want to take up too much more of your time because I'd like you to finish your point.
No problem. So as I said, it's ruled out the most rigid version, which is exemplar confusion. This we believe it can still be accommodated by more flexible exemplar model. Now, there's another price that is interesting, is that those prices that people would report outside of the range of the two distribution. We believe that this price of 4, for instance, here, would be much harder to reconcile with an exemplar model, because again, it's not a price that people can interpolate between the two distributions. It would require people to extrapolate and to make a judgment that given what they know about the dispersion of the distribution, a price like this should be here. Again, I'm sure an exemplar model theorist could write a model that would predict the appearance of this price, but we believe it's a less parsimonious explanation than people have formed an overall sense of dispersion and are mistakenly applying it to the distribution. And so to wrap up very quickly those results, we again replicate the dispersion spillover. That is when the other distribution had a high in orange versus low in blue amount of dispersion, people report higher dispersion. And then when we look at the phantom values, the number of phantom values, we find that people, report more of them when the other category had a higher amount of price dispersion. So again, that's incompatible with a pure exemplar confusion. And when we look just at the outside phantom values, so not the one that falls in between the two distributions, the one that are on the outskirts, we also find more of them. So to us, that's suggestive that people do not just store dispersion as a list of numbers that they remember seeing, but also encode across category an overall sense of variability, and also rely on these intuitive statistics to inform their judgment. So I'm going to wrap this up here. We believe that there's a lot of things to explore in terms of why there is a dispersion spillover. That goes back to Jen's comment. It might be cognitive capacity constraint, in which case we should play with the number of exemplars presented and see if it moderates the result. It could be an adaptive heuristic that people know that dispersion is biased in small sample, and so they're voluntarily pooling across category to increase information. And finally, we'd be thrilled to explore how is the intuitive dispersion form? Is it close to the mathematical formula? Does this reflect prediction error or surprise that people have when encountering numbers? So anyway, that's all future direction. Thank you so much for being here. If you have questions or feedback, you can reach me on my website, on Twitter, on email. And thank you again to Uri, Joe, and Leif, and to you all fantastic panelists for being here today.
Thanks a lot, Quentin. Thanks to all the panelists, and thanks to our audience. This has been really great. I hope to see everybody again next week. All right, enjoy your weekend. Take care.